Hi Matt, lovely to have you here. Thanks very much for coming and joining us. I think before we deep dive into AI, can you give us a little bit about you, your role at HPE, a little bit about your background?
Yeah, sure. I'm a chief technologist, so CTO at Hewlett Packard Enterprise, and I've specialised in artificial intelligence for the past 6 years. So that kind of means I was doing all of this stuff before it became really super trendy. So my academic background is through computer science and then up into the AI route. And at HPE, it means I cover the whole portfolio right the way through from the things we do with services, through compute, storage, networking, and up into the software layer. And it means I work extensively with customers, both in terms of trying to understand their requirements, as well as engaging with our deep relationship with partners around how we can leverage HPE technology and the great relationships we've got to really drive some innovative solutions and tackle some big problems that our customers are trying to tackle.
So Matt, given we just hear about AI in the news on a daily basis, every time you turn it on, how do we actually get to where we are now?
So AI, the term artificial intelligence was coined in the 1950s in a working group in Dartmouth University. So that's Dartmouth in the US, not in the UK. And during that working group, they created some of the foundational maths. We could argue that it's got its roots much, much deeper back in history, but those were some of the key breakthroughs. So, I mean, imagine creating some mathematical models that it was going to take, this length of time to generate the computational capabilities to run them. So, AI has been evolving in academia for decades. And some of the things that are great when it comes with academia and their involvement with this sort of technology, they're great at documenting things. They're great at building frameworks, and they're great at making it open source so anybody can use them. The key breakthrough, the massive acceleration that happened that moved AI from sort of living in the academic world to moving in the mainstream, was back in 2012. A guy called Alex wanted to enter an algorithm that he'd created into a competition. Now, you could tell he was a computer scientist, not in marketing, because he called his algorithm AlexNet. But he'd also worked out the level of computational power required wouldn't get him ready for this competition called ImageNet, which was going to be in about 12 months' time. And he spoke to a lot of his lecturers, and we can accredit his PhD supervisor, who was somebody called Geoffrey Hinton, who actually credits the success of AlexNet to NVIDIA. So Alex ported his algorithm from running on a CPU to running on an NVIDIA GPU. And he used CUDA, the NVIDIA frameworks, and that accelerated how well his algorithm performed because it reduced the training time.
And this is the processing power?
Yes, exactly. The processing of the construction of his model. And he entered it into this competition called ImageNet. And he won it so successfully that even NVIDIA were like, wow, there really is something in this GPU technology when you combine it with artificial intelligence. And NVIDIA, invested significantly in building out their portfolio, changing their, the mix of how they were moving from a traditional graphics gaming company into the AI world. A huge partner of HPE, and we've co-developed a whole bunch of technologies together to give us NVIDIA certified GPU servers from HPE. And that was some of the foundational capabilities that accelerated AI into the mainstream. And what that means is it's now a much more readily available technology. We've had academic research for decades, and this breakthrough, which was over 10 years ago, that really has made AI a technology that's readily deployable inside our customer and to help them achieve some of the key challenges.
And that technology lends itself not only to AI, but to HPC, deep learning, machine learning. I don't know, sometimes it's a bit confusing about what the difference is between the different acronyms, if you like. I don't know if you could elaborate on it, give us some sort of clarity on the difference between deep learning, machine learning, AI.
Yeah, happily to break that down. I mean, it's a common problem. It's probably best though if I switch to a white wall to draw some pictures. So one of the key things I can do is sort of draw some out. So we're going to explore the layers and lexicon of artificial intelligence. So if we start by imagining it as an onion, because we'll slowly peel back the layers to get to the depth of the individual components that make a machine appear to be artificial intelligence. So let's start off with the outer layer, which is AI. So there are two main types of artificial intelligence. The first one is strong AI. So strong AI is the concept of an artificial intelligence capable of operating at the same level as a human being. We're not there yet. This is the stuff of science fiction. And I would like to think, being an AI evangelist, that it will happen within my lifetime. However, today we are in the realm of weak AI. So weak AI is an artificial intelligence that is capable of operating inside the bounds of a single knowledge domain. If we break that down a little bit further, we get this concept of machine learning. So machine learning is an algorithm that is trained, it isn't explicitly programmed. So if we think about traditional software development, we have conditional statements. If X, then Y, else. So in these conditional statements, I have defined a rule. If X happens, then do Y, otherwise do something else. With machine learning, I teach by example. So I show the algorithm lots of different examples of the data and then allow it to define its own rules associated with that data. There are lots of different machine learning techniques that span a variety of complexity and explainability. The most complex is an artificial neural network. So an artificial neural network is a biologically inspired mathematical algorithm that is an attempt to replicate the way a biological brain operates. It does this using probabilistic mathematics. And that probabilistic mathematics technique is called deep learning. So deep learning is a mathematical implementation using an artificial neural network that is a type of machine learning that makes machines appear to be artificially intelligent.
That was great, Matt, but come on. You've missed generative AI. Tell us about ChatGPT. It's on everyone's lips at the moment, so I want to know more about that, please.
Yes, hot topic. To my thinking, two of the biggest things in the AI space have happened within the past just under 10 years. One was the passing of the EU AI Act, so legislation around deployment of artificial intelligence systems, passed earlier this year. Nobody's heard about it. The other one was the launching of ChatGPT. So ChatGPT is an implementation of a large language model, type of generative AI. And actually, it goes back to some seminal work back in 2017 when something called a transformer was created. Not a robot in disguise, but a type of artificial neural network. So it's a specific implementation of what I drew up a little while ago to talk about representations of biological brains using mathematical techniques. That's what large language models are. And really, there are sort of some of the fundamental approaches to the way that we're doing generative AI. They do go back much longer than that. So there are other implementations of how to tackle sequential data, like words.
Yeah.
But really, it was this transformational paper in 2017 adopted by OpenAI, and then subsequently the launch of ChatGPT that's really kind of captured everybody's imagination in the generative AI space.
Unlike the paper which everyone's heard about.
Yeah.
No, thanks for that. I mean, what are HP doing in this space? HPE doing in this generative AI space?
Yeah, so we've got a couple of things. So firstly, we are launching a collaboration with an organisation called Aleph Alpha. So they do have a large language model which will be running on HPE in a colo environment. That'll be running in the US sometime this year, 2023, and then we've got a European equivalent deploying next year, 2024. If you want to do something earlier than that, then we've got some software capability in the form of something called the machine learning development environment, which simplifies how you can construct large language models yourself.
Well, why wouldn't you just use ChatGPT?
A couple of challenges when it comes to the deployment of ChatGPT, things you need to think about. So the first one is copyright. So when you ask a question of ChatGPT, you own the copyright to that. What ChatGPT produces, the copyright ownership depends per country. So in the UK, as an example, copyright can be owned by software because the ownership of that transfers to the creator or the owner. So as a result, whatever ChatGPT produces, you do not own the copyright for.
It's quite more complex than you would first imagine, right?
There's a parliamentary working group currently elaborating through this problem to try and think about the implications of copyright ownership when you're using large language models owned by somebody else.
So what HPE is bringing in now, coming into play next year, this is going to counter that?
So it would be an open source deployment, and because of the way that we're going to deploy it, we anticipate that the copyright, depending on what the working group, the decisions the working group arrive at will influence the copyright decisions that are made around it. Another area where if there are specific copyright considerations is the deployment of a large language model on-prem. So in that instance, what you can do is you can use the machine learning development environment and simplify the deployment. If you go to a place called Hugging Face, which is an open source repository, or mainly open source repository for large language models, there are about 270,000 models that you can choose from. So it is a case of choosing the model based on your specific needs. One of the problems that we find with large language models is they hallucinate, which is a flash technical term for they just make stuff up. So if it may well be, if they don't understand your data, they will hallucinate it.
Have you got a good example of that you can share with us?
One of the common ones used is there a McDonald's in Heathrow Terminal 2? Okay. And ChatGPT might well say, yes, there is a McDonald's in Heathrow Terminal 2, and there isn't, just because ChatGPT doesn't know whether or not there is or isn't, so it makes it up. It wants to provide you with an answer. So this is why, if you look at all of the big large language model implementations from the hyperscalers, they're all telling you to fact check what the large language model is telling you. If you deploy on-prem and you use some of your data to go through a process of fine-tuning, which means you take a general model, ChatGPT is an example of a general model, and you take some of your data to add to it so it knows more about you and your organization. By taking the open source model with an Apache 2 license, applying your data to it, you own that copyright. If you were to use the GreenLake for LLM model, again, you can deploy this localized understanding of your data to fine-tune the model, meaning that you own the copyright to it. You can also make it more comprehensive because with your large language model deployment, you can also give it a knowledge store in the form of a vector database, to give it its exact title. And what that knowledge store is a detailed understanding of your environment that helps the large language model provide you accurate information and significantly reduces the risk of hallucination. Wow. And what we've been doing, both inside HPE and also in academia, is using ChatGPT as a baseline and then working out whether or not fine-tuned large language models with knowledge stores perform better. And they do. So as a result, what we're seeing is when organizations take their data, use an open source large language model, they can get better results than if they use a general model such as ChatGPT.
And how are you, HPE and NVIDIA, supporting customers, partners in being able to do that on-prem at the moment?
Yeah, so NVIDIA have got a whole suite of software libraries called NeMo, which allows you to go through the process of building using foundational models, which you can get from NVIDIA, which are a very, very quick way of accelerating how you are to deploy large language models that are specific to you, your organization's taxonomy, and how you can apply that data in a way that reduces significantly the possibility of a large language model
Is
hallucinating.
that like a subset of their NGT? I've heard of the NVIDIA NGT, the baselining. How does NeMo fit into that or work alongside it?
So you can use the NVIDIA cloud as a primary way of gaining access to a whole variety of of models that you can use for a variety of purposes. NeMo and Megatron, which is one of their open source versions, is
So
definitely
they're
available.
examples of them.
Yes, yes.
Great, thank you.
And just explain a little bit further the LLM, how that works, in terms of building the response, differently to how you would typically have a response built, and the pattern of the words, for example, or the patterns of the response.
Yes, the best way of thinking about a large language model is it's almost a next word predictor. So you put in all the words of your question, and then it will take that question and it will predict one word at a time. So if you've used a hyperscaler large language model, you'll notice that they spit words out and then they pause and then they spit words out. And that's because they're building the next word in the sequence ready for you to use. So a large language model really is the understanding of the way that words link together. And that allows it to provide some probabilistic mathematics of the next best word in the sequence. But it takes all previous words as input. Where it starts to get complex is a large language model is limited on the number of words that they can take as input because they get tokenized. And depending on the large language model you've got, the maximum is about 4,000 words for any single query, and every single word that it produces fed back through itself. Again, you can mitigate this risk by using this knowledge store, a way of capturing some of that information, and by using a process called prompt engineering. So prompt engineering means that you can help the model to query better. I'll give you an example of prompt engineering. So this is prompt engineering through chain of thought. We would call it show me workings out. So if you used an earlier version of ChatGPT and you said, Matt has 6 apples, Lynette eats 3 apples, how many apples does Matt have left? ChatGPT would say 6. However, if you use chain of thought, in the same example, Matt has 6 apples, Lynette eats 3 apples, how many apples does Matt have left? ChatGPT will now, because it's been updated with chain of thought, say, Matt has 6 apples. Lynette eats 3 of Matt's apples, so Matt has 3 apples left. You can type that into ChatGPT, and if you used an earlier version, you'll see how it's been updated to now perform chain of thought, because using this process called prompt engineering allows you to get better and more accurate results out of your large language models. So it means if you are thinking about a large language model deployment, I'll say this many times, AI is a team sport. It is about bringing in people who understand how this technology works, who can understand how to make it successful when it comes to deployment into your organization.
So it's the right partners, the right skills, the right mix of people.
Yes.
Well, thank you. I'm looking forward to the next session.